Okay, so this is for Anatomy and Physiology 1, Chapter 22, Part 4. We're still talking about the adaptive immune response, but now we're going to talk specifically about antibodies and then essentially immunological memory, how that works. So another name for an antibody is called an immunoglobulin. So they abbreviate antibodies as IgS. Same thing, okay? We talked about how B cells, when they're activated, they can become, through clonal selection and differentiation, a cell called a plasma cell. These plasma cells are what make the specific antibodies. A little bit about the anatomy of the antibody. I've talked about before how they're Y-shaped, okay, most of them. And they're actually composed of 4 peptide chains. There's 2 heavy chains and 2 light chains that you'll see on the next image. They're linked together via bonds called disulfide bonds, and there's the Y arrangement that I talked about. Part of the antibody is variable, meaning can change from specific antibody to specific antibody. That variable region, like if you're thinking of a Y, right? Can you see my Y here? Like a Y, okay? So the antigen or the variable regions would be the very tip, also called the antigen binding site. So that's where the antigens bind, and that gives it its specificity. And the stem, or the rest of the antibody, is specific for each class because there's 5 different classes that we're going to talk about. And this is an image of an antibody. So here's the Y shape, as you can see right here. The antigen binding sites, or the variable regions, are right there. So the antigens will bind to that area. Here is the stem region, which is the same for every class of antibody. So this is an IgG antibody. So every IgG antibody is going to look the same right here, but it's going to be different up here. This is a heavy chain. This is a heavy chain. This is a light chain. This is a light chain. And this is the hinge region, essentially, where it can, okay, here's the antibody, where it can bend and move like that. How antibodies destroy, or how are they involved in the adaptive immune system? How are they effective? They can neutralize, they can activate complement, something that's called complement, or they can help with opsonization. Here's the images of all 3 of those. So neutralizing, how they do it. So here the bacterium is the orange oval, and the antibodies are the blue Y's here. So they can essentially hoard together, causing agglutination. That's when the antibody hooks to the antigen, click, 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 and it causes this bacterium to be neutralized. It makes, normally it was soluble, suddenly it's insoluble. So when it's in that form, it's more likely to be found by phagocytic cells or other cells that will just come and destroy it. Here is the activation of complement. So antibodies bind, complement protein is attracted to that. That complement protein, like I said before, all it does, punches walls in that bacterium to cause it to explode. Opsonization, think phagocytosis. And see, there's the bacterium and antibodies are all over it, signaling, ding, ding, ding. They sit there and wait. It sends signals to the phagocytic cells that come around it. That process is called opsonization. Let's talk about the 5 different classes. IgG is majority of the antibodies are IgG, 80% of them. This is the only antibody that crosses the placenta before you're born. So when you're born, the only antibody that you have, only class of antibodies are IgG. IgG provide long-term immunity. IgM is your biggest. That's what pentameter. You'll see the image here. It'll make it more clear. It actually has 10 binding sites. The monomers only have 2. IgM, great at activating that complement system right here, the punching holes and that kind of thing. But it doesn't last as long. It's not as long-lived as IgG. But It's also the first to appear in an immune response, IgM. IgA is, we're going to find a lot in bodily secretions, sweat, tears, saliva. This is interesting. Breast milk. So when a mother nurses or breastfeeds her child, that's the second antibody that the child receives. They already have IgG, now they're going to get IgA. IgE is involved in allergic reactions. It's very small. It's less than 0.1% of total antibody. IgD, not really well understood. We know it has a wide variety of functions, IgD. There's just this image. All of these four are monomers, so they combine 2 antigens at once. This is IgM, combine 10. Okay, so now let's talk about antibodies and the process of immunological memory. How does your immune system remember antigens? So after that initial encounter, so the first time your body encounters an antigen, it's called the initial encounter, memory cells are produced. Okay. So this primary response is what happens antibody-wise during a primary response. First exposure, you can see IgM is the first one to appear, followed by IgG. And you can see over on the y-axis, antibody titer, essentially the amount of antibodies. So you get sick, eventually antibodies are produced, and they go up in number, they do their job, you get better, they go down in number because most of them aren't long-lived, they're not memory, and IgM definitely isn't long-lived. Okay. This shows the secondary response. So the second time you come in contact with that same antigen, look what happens. Not only is the response or the amount of antibodies produced on both types, or for sure the IgG, stronger, but it's a quicker response, okay? Look at that. So in this case, it's faster, more antibodies, and you don't actually get the effects or the sickness. Your body essentially takes care of it before you even feel sick. Cool. So there are a few ways you can gain that immunocompetence or that memory. You can acquire it naturally. So your body makes everything without the help of natural medicine or modern medicine. Artificial immunity is due to modern medicine. So those are 2 categories. Also, it can either be active or passive. Active is when your body is making the antibodies. Passive is when you are given the antibodies that are already made. When your body actually makes the antibodies, it's more long-term. It's long-term memory. Passive is short-term. Doesn't last as long. And these are the 4 specific examples of that. Natural active. Your body coming in contact with a pathogen. Let's say I contract hepatitis A. That's a pathogen. My body itself will make antibodies. Natural active. Natural passive. I get it from my mama in my womb or from breast milk. Naturally. But my body is not making the antibodies. My mother is giving them to me. Natural passive. Artificial active. A person, this is modern medicine, is a vaccine that's given to you, either that it's a weakened or dead, essentially, pathogen that causes my body to make antibodies. Artificial active. Artificial passive, modern medicine, you are given the antibody. Not very many cases of that. One is the rabies vaccine. Last slide here. As you age, your immune system declines. A few things that happen. That thymus gland that's on top of the heart, actually at puberty, it atrophies, totally shrinks. So we have a decrease in helper T cells. And so a diminished specific immune response. B cells and T cells. Also, as you get older, your body creates more autoantibodies, simply antibodies that are attacking your body's good cells. Also, increased incidence of cancer, just more likely. A lot of older people I know, one of my grandmas in her 90s died cancer. No really other reason, just her body was so old, so many cells that were just slowly deteriorating, which led to cancer. So that is the end of part 4.